Hi, it's Edutainium, and today we are talking about a famous debate. Why is 0.9 recurring equal to 1? If you didn't know, a decimal with a dot or dash on top of it means it's a recurring decimal. 0.9 recurring is a recurring decimal, and it's very special because it is equal to 1. They might seem like different numbers because one starts with 0 and the other starts with 1. The number line proof. But if you look at the number line, if two numbers are different, it is defined that there is at least one number between them. For example, no matter how small the two numbers are, as long as they're not infinite, you can always just add a number after the smaller number, and that makes it larger than the smaller number, but less than the larger number. Except that 0.9 recurring is infinite. It doesn't terminate. So there could never be a number between 0.9 recurring and 1, because 0.9 recurring goes on forever, and you cannot add a number after it, because there is no after it, since it never ends. So if there's no number between 0.9 recurring and 1, they are the same number. You might then say, what if you multiply 0.9 recurring by 2? That makes it 1.99999 until it ends with an 8. Because 9 times 2 ends with the digit 8. But now you can have a number between them, can you not? Between 1.99998, which is what we said was 0.9 recurring times 2, and 2, you can have 1.9 recurring, couldn't you? But in reality, multiplying 0.9 recurring by 2 doesn't end with an 8, because the decimal never actually ends. Every time a 9 is multiplied by a 2, it carries a 1 to the next digit, and that next digit is always an 8, and plus that carry of 1 always makes it 9. This process continues infinitely, and you will never see an 8 at the end, since it never ends. So you see the problem there? 0.9 recurring times 2 is 1.9 recurring, and using our logic before, because 0.9 recurring is 1, that times 2 is equal to 2. So 1.9 recurring is 2. There is no number between 1.9 recurring and 2, just like between 0.9 recurring and 1. The algebraic proof. You might have seen this proof in other videos, but it still is quite fascinating. If you let x equals 0.9 recurring, then 10x equals 9.9 recurring, since multiplying by 10 just means moving the decimal point one place to the right. Subtract x from both sides, and you get 9x on the left side and 9 on the right side, since the recurring 9s subtract each other out. Now you have 9x equals 9. Divide both sides by 9, and you get x equals 1. And remember that x is equal to 0.9 recurring as well, so 0.9 recurring must equal to 1. The limits proof. 0.9 recurring means 0.9999999 infinitely many nines, and that means it gets infinitely close to 1. That's exactly correct in a way, but when we deal with infinity, we deal with limits. We could say that it gets so close to 1 that the repeating nines eventually fill in the gap, arriving at 1. Say you write 0.9 and add a 9 after it, again and again. Each term gets closer and closer to 1. That 1 is called the limit because it approaches 1. You can say that the number of nines is called n. Then when n gets larger and larger and approaches infinity, that means when there are more and more nines, the value gets closer and closer to 1. And in math, a recurring decimal is defined as its limit, like how 0.3 recurring is a third, and 0.6 recurring is 2/3. Since 0.9 recurring converges to 1, the limit, it is equal to 1. You can also say if 0.3 recurring is a third, 3 times that will be 1, which is also 0.9 recurring. I guess that makes recurring decimals easier to deal with. The geometric series proof. Last proof, we can use an infinite geometric series to do that. We can first separate 0.9 recurring into infinitely many decimals, because 0.9 recurring is simply equal to 0.9 plus 0.09 plus 0.009 plus so on. That line of sums is our geometric series. There's a formula to calculate the sum of an infinite series. S equals A over 1 minus R, where absolute R is less than 1. S is the sum, A is the first term in the series, and R is the ratio of how much the terms vary each time. Absolute R means the positive value of R, so if the ratio is negative 0.8, the absolute R is positive 0.8. It has to be less than 1, or else it means that the values get larger and larger to infinity, meaning the sum is infinity. In our case, A is 0.9 and R is 0.1, which is less than 1 because every time the term times 0.1 is the next term, which explains the ratio. S, the sum of this series, is equal to 0.9 over 1 minus 0.1, which is 0.9 as well. So 0.9 over 0.9 is just 1. The sum is 1. So 0.9 recurring is equal to 1. I gave you 4 proofs of how 0.9 recurring is equal to 1. Hope you found it interesting. If you're still not convinced, feel free to search up more proofs online. Please consider subscribing, liking, commenting, and sharing. And don't forget to hit the bell. Feel free to have a look at my other videos or playlists. Have fun with maths, and see you next time.